Okay, so in this lesson we're going to learn the cosine rule. So the learning intention is the knowledge of the cosine rule and the skill in applying this rule to solve problems. Okay, so to be successful we have to know what the cosine rule is. We know when to apply and use the cosine rule and correctly calculate missing sides or angles of non-right angle triangles. Okay, so imagine we have a triangle ABC. So we want to basically derive the cosine rule. So this is going to be this side is going to be little c, and this is going to be little b. Now, looking at triangle ACD, notice that from my angle A, I've created once again a perpendicular line to make two right angle triangles, and I've called that line or that side P. Okay, and notice that here I've called my side CDX. Now this whole side here is actual A. So if I'm going to call this X, this side, the remaining bit is going to be A minus X. Yeah, so because all this is A, I'm going to take away that, so this part here is just A minus X. Okay, so in triangle ACD, angle C, so cos C, okay, remember that's going to be the adjacent over the hypotenuse. Okay, so that's going to equal X over B. And in triangle ADB, okay, so before I look at this triangle, so we got, triangle ACD, we've got cos C is the adjacent over the hypotenuse, which is X over B. And so let's just change that to make X the subject. So we've got X is actually worth B cos C. Okay. Now, looking at this triangle ACD, and using our rules of Pythagoras' theorem, remember that b squared equals the sum of the other two sides squared. So that actually equals p squared plus x squared. Okay. Now, using the other triangle ADB, and looking at this relationship, we actually still have the hypotenuse here will be c squared, and that's going to be equal worth p squared plus a minus x squared. If I expand this, I'll get p squared equals a squared minus 2ax plus x squared. Okay, and what I'm going to do is I'm going to just rewrite this. I'm going to bring this x squared up to the front here. So c squared is worth p squared plus x squared plus a squared minus 2ax. And the reason why I've moved that is because p squared plus x squared I've seen before. I've seen it over here. And that's technically worth b squared. So I can rewrite, instead of writing p squared plus x squared, I'm going to write it as b squared. A squared minus 2ax, just write whatever's left. Okay. We're nearly there. We want to get rid of this x. Now, x, we know, is worth b cos c. So c squared is actually worth b squared plus a squared minus 2ab cos c. So instead of writing x, I write b cos c. And this here is the cosine rule. Okay. So let's do some examples. So here I've written the formula. So c squared equals a squared plus b squared minus 2ab cos c. So it's just Pythagoras' theorem minus 2ab cos c. and we use that to find an unknown side. If we want to find an unknown angle, well, we can rewrite this. So what I'm going to do is I'm going to actually bring this whole thing to the right-hand side. So I've got 2ab cos c, and that's b squared plus a squared. I'm going to minus c squared from both sides. And then just divide by 2ab. So cos c is worth b squared plus a squared minus c squared over 2ab. And now obviously if we want to find, because we're finding an angle, it's the inverse of all that. Okay, so let's do some examples. So where do we have to look? When do we use the cosine rule compared to any other trigonometric rule? So we're using cosine rule when we have basically two known sides and the inclusive angle, the angle that's in the middle. Yeah. So we're looking for two sides with an angle in the middle, and the c squared, the angle that we're trying to find is the angle opposite the known. This is the side opposite the known angle. So here we have the perfect thing. We have the two known sides. We have an angle in the middle, and we want to find the opposite side. So using the formula, c squared equals a squared plus b squared minus 2ab cos c. In this case, the unknown side is the side that opposite the angle. So that's x squared. A squared can be either one. So let's do 4.2 squared plus 6.7 squared minus 2 lots of 4.2 lots of 6.7 cos, and c is the degree, so 101 degrees and 15 minutes. Plug that into our calculator. We get 73.509683332. Now that does not look right, because we get 4.2 units and 6.7 units, and all of a sudden we get 73 units. The thing is that this is x squared. So like Pythagoras, we need to do the square root of this number. So the square root answer, the side length is 8.6 units in measurement, 1 dp. All right, and providing the answer similar to the way the question was given. Okay, so here we go. Once again, we've got the two known sides, and we've got the angle in the middle. That's perfect for the cosine rule. So we get c squared equals a squared plus b squared minus 2ab cos c. Okay, let's say a is 8 squared, b is 5 squared, minus 2 lots of 8 times 5, cos c is 47 degrees and 32 minutes. Plug it into our calculator. 8 squared plus 5 squared minus 2 lots of 8 lots of 5, cos 47 degrees and 32 minutes. Gives us 34.987. We need to square root that, so c is worth 5, we went to one decimal place, 6 meters nearest whole number, or nearest meter. Okay. Here we want to find what theta is, so we're going to use this side, or this rule. So theta is the inverse of a squared plus b squared minus c squared, over 2ab. Okay, so now it's important to kind of know which is which. So there's your angle. Yep. these sides that are on either side of the angle, that make the angle, they're going to be your A and your B. So 6 squared plus 6 squared. And the opposite is going to be your C. Okay, so if we're going to plug this into a calculator, so shift cos, we've got 6 squared plus 6 squared minus 7 squared over 2 lots of 6. Remember, it's a degree, so we've got to press degree meters in seconds. They want it to the nearest minute, so 71 degrees and 22 minutes. Okay, using this one, so this, okay, so this is going to be your A, this will be your B, that's going to be your C. So cos, so C equals inverse cos, A squared plus B squared minus C squared over 2AB. So 6.1 squared plus 5.3 squared minus 10.4 squared over 2 lots of 6.1, 5.3. Okay, so shift cos 6.1 squared plus 5.3 squared minus 10.4 squared over 2 lots of 6.1 lots of 5.3. Press degree minutes seconds, 131 degrees and 31 minutes. Okay, and that's what theta is. So, just to finish off, as a summary, using trigonometry, the first questions we should ask, so what rules or what formula? So the first question is it a right angle triangle? Okay, is it a right angle triangle? If you say yes, then we have to use SOHCAHTOA, or your trig ratios. Okay, if you say no, you get two options. If you have matching sides with angles, opposite angles. If that's the case, then we're going to use the sine rule, which was A over sine A is B over sine B, which is C over sine C. Yeah, so that's when you've got. So these are non-right angle These means non-right angle triangles. Okay, and that's so we've got this with this, and that with that, and this with this. Yeah, so we're trying to match pairs together. If we have two sides surrounding an angle, yeah, we're going to use the cosine rule. And so you're going to have c squared equals a squared plus b squared minus 2ab cos c. And what we mean here is if we have a triangle, we have this and that, and we have that. So what we're looking for is we're looking for this huggy shape. Yeah. If you have that hug, that's when you're going to use the cosine rule. Okay. Matching pairs is sine rule, hug or the inclusive angle, is the cosine rule. Okay, thank you.